Welcome back to the next session of our course, Sustainability through Green Manufacturing Systems and Applied Approach. So, we are going through the smart factory development model in this week. So, we are at the kind of edge of that, and I am here going to develop a smart factory using the data that was developed. So, this software which I am going to use is PLM or Siemens PLM software, which has NX Technomatics and Team Center as its major areas, and different modules of all these areas are available. Now, what is NX? NX is actually digital designing. This is digital manufacturing, and this is digital life cycle assessment or life cycle management better. So, this is a kind of a design software where the idea that is generated is transformed into a model. That model is kind of, for example, if I need to develop a model for this pen, all the specifications would be given and this pen model would be made here, all the assembly here, this back tip here, or this back side of the pen, this tip, all these things we need to have the dimension and specifications, and this can be developed. Then the next step is to manufacture this one. To manufacture this one, because this is a plastic pen here, different processes would be there. For example, extrusion might be there, compression molding might be there. Those machines are to be arranged in an order. The kind of layout here may be process layout or maybe product layout, which we have seen in the previous lectures. So, that is done by digital manufacturing here. This digital manufacturing is technomatics. This also is known as plant simulation, and this is the thing where we will have more focus in this lecture. Next is team center. Team center involves all other things, the life cycle management. By life cycle management I mean all the stages of life cycle management, right from the procurement, right from purchasing to the marketing, all the factors are here in team center. So, let us start with our technomatics software here. So, I have taken a computer that has a licensed version of this software here in the studio using a remote access. So, this is the home page. When you will open Technomatics Plant Simulation 10 software, this is the home page we have here. So, in this we have create model. So, when I click on create model, it will ask the basic objects here, that what kind of objects would you like to use. So, these are all the basic objects here. So, then in libraries we have certain other objects. So, for example, if certain special requirements are there, special automated guided vehicles are required or 3D conveyors are required, these models can also be chosen. So, for instance, let me choose this one. So, we will say apply or OK. So, this is the work area that is generated here. So, also I have a library here. So, in this library all the tools are available, those we have selected. So, this is a connector. The using connector, the objects that are inserted into the simulation model here are connected using this one. For example, if I choose a single process, so what is a single process, a parallel process, these things we have gone through. Dr. Deepu Philip has given you details of this one. So, a connector would connect a process with the other process. So, I am just dragging this to the work area here. The connector would connect this process to the other process. I am just kind of dragging it and dropping it here. So, next I have is event controller. So, what is event controller? When you are modeling, event controller is required. That is, one can select the settings for controlling the simulation run, the time for which simulation is run, that can be selected here. So, this is the event controller. So, let me first start from something. These are two processes here, single process, a single process 1. There has to be some source, that is some input from which the material is coming, then there has to be some drain. These are the essential elements of our product, of our layout here. So, this drain, if I connect this to my single process here and connect the second single process to my drain here, I will obtain a model. So, this is the event controller that would run this model. So, let me run it in real time. Apply, OK, then run. So, an object, a unit, a mobile unit has come in and processing is being carried out. So, we have yellow and green dots here. The green dot means processing is being carried out, and here yellow dot means this one is blocked. Blocked means some other processing is being carried out in the successor event here. So, this is just waiting, kind of waiting for that. So, because this is the real time model, it will take full 1 minute. If we see, if I right click on this and open, the processing time here is constant and it is 1 minute here. So, this processing time can be changed. We can check, we can select the distribution, uniform distribution, normal distribution, log normal distribution, the kind of distribution our process follows. See, after 1 minute, this mobile unit or our workpiece has moved to the other process, second process here. So, this time is constant here only, constant and 1 minute. So, in case of normal distribution, it is asking stream, mu, sigma. Stream here is the random variable, the seed of random variable. That is, when we have random variables, it starts from something. So, this is the seed, stream is that thing. Mu is the mean of my normal here, normal distribution here. Sigma is my standard deviation of the normal distribution. Lower bound and upper bound can also be given here. So, these times could be put here. Now, let me run this process a little faster. Also, in the settings we can see when is our process going to end. So, I will put here time 0 0 0 0 or I will put 0 0 0 8 0 0 0 0. So, this would, if I say apply, this has given the end time as 8 hours. So, for 8 working hours my process would run. So, it is applied and then I will run it 5 times the real time. So, by changing the time to 5 times the real time, we can see that this time would be running 5 times faster. That is, the 1 minute would come in 1 minute by 1260 by 5. In 12 seconds, 1 minute would be completed. So, after 1 minute, the job is moving forward to the next step. But one thing you might have noticed, this grid, the grid video which you are seeing here is, this is actually 1 meter. This distance is 1 meter. This distance also we can change here, the distance between 2 points. So, you might be noticing here that there is no time elapsed between these two processes because it is connected directly. So, this is not right practice to do. So, actually it should have a conveyor or some kind of material handling system that transfer materials from one process to the other process. So, I can also name this process, rename this process as well. First of all, I will say let me say it is milling. and let me say this is drilling. Okay. So, we have line here. The line here is a kind of conveyor belt that would move the material from one place to another. So, also we can have pick and place. So, the pick and place is used when the two machines are a bit closer, that when this robot can pick from one machine and put it to the other machine. From milling to drilling, it can pick and place. But when the machines are too far, this kind of material handling system, pick and place kind of material handling system would not work. So, I will put the processes or the machinings about, so this is 1, 2, 3, 4, I am counting the points 1, this is 0, 1, 2, 3, 4, 4 meter apart. So, I will put it more closer. So, it is 1, 2, 3, 3 meter apart, and this pick and place process would put it here. So, let me run this one. So, what you will notice here, okay, let me make it faster, or we can do it faster from here itself. Apply, okay, now run. So, you can see it is going very fast, but this one is not moving. Why? Because we did not connect this. So, the connector has to go like this. This connector is not direct, I am deleting this one, and this process is being connected through the pick and place. So, if you see now, this process milling and drilling is connected through this material handling system. So, these simulation softwares are GIGO, garbage in, garbage out. So, it is the skill of the operator or the user or the manager who is using this one. He has to make the right connection, he has to put the right data in, right distribution, right times, right location of material, then only the right or correct result would come there, the throughput would be correct. Otherwise, a minor mistake, or even I would say, so a micro level mistake can even lead to the macro level difference or errors in the final throughput that is being obtained here. So, this is connected here. Now, if we see, this is running very fast and this pick and place thing is working. So, this just rewinds the process, not when it takes it to the 0 time. So, in the event controller, I will run it real time into 10, apply, okay, go. It is picking, it will pick and place. So, it is real time into 10 times, that is in about each 6 seconds it is picking and placing though. So, what is happening after this? It is just going out, it is drain is placed too far here. We also need to have a conveyor. This conveyor also has a speed associated with it. If I open this one, it will say speed. Speed here is 1 meter per second. The length of the conveyor is 5 meter. So, here also I can put a conveyor between drilling and the drain. Let me put another line here. So, I can change the length of the line from this input. Let me say this line is 15 meter. If this doesn't work, I can even count these points, point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. I can count the points and put the meter values here. So, I think this would be close to 25 meters. 25 is too large. So, let me use my cursor to make it shorter. So, any input method, mouse or keyboard can be used to give it right size or to pick and place the things, to drag the things here. So, now you would see the process would run here also. The conveyor would also carry the mobile units to the drain. Right? Okay. also we can see the 3D model of this one, the 3-dimensional model. So, this is beauty of this software. The 3-dimensional model can also be seen. If I zoom in it, let me run the model here, run or go to back and then run. You can see the 3-dimensional model here. Right, the material is going out to the drain. So, we have event controller here, these are called as mobile units. This is my source, process 1, that is milling, drilling, pick and place robot, line and drain. So, let us stop it. So, let me come back to my 2D model. So, what tool we have here in our material flow? Connector, event controller, frame. Frame is used to manipulate the objects, like it is the plant simulation objects as well as vector graphics. These are drew and inserted into the frame. Interface is something that is used to enter the maximum number of connections. The side of the icon of the frame at which the interface is to be located on top or right or bottom or left, this can be used. So, next is source, that is the input. So, drain is my output here. Single process is a kind of a single processing unit that receives and processes a single mobile unit. Now, parallel process is the kind of processes those are placed in parallel. If I say parallel processes, this is 2 into 2 matrix here, that is total 4 processes of not similar but same kind, that is that drill. For example, if I say the drilling machining of same type, not the drilling machine, one drilling machine of one capacity, another drilling machine of another capacity. So, these single processes is not kind of process layout. In process layout, we have different kinds of drilling machines, those are placed in one section. So, this is parallel processes, that is the same kind of drilling machines are put there in parallel. So, in this case, if we need to put 3 processes, we can have 1 into 3, or if I say here 3 into 3, that would make it 9 processes, because this is in x and y dimensions, this work as a matrix here. So, next is assembly. Assembly is, so example, when 2 components are coming from 2 different lines, this is one line, I can generate another line or maybe copy this line. The drain has to be same, this is a single drain, and we could have an assembly in between. So, this connector would go to my assembly, there would be another connector that would connect my second line to the assembly, and this assembly would be connected to the drain. So, in this case 2 materials are being produced. For example, we are kind of making nut here and bolt here and assembling it, and then it is coming out. So, one thing I would like to tell here is that this time is selected for 8 hours. We can see the throughput here. So, I will run this process in the fastest way, apply. So, this process would run in instantaneous time now, start, finish. Now, this is done to find my final throughput. For this kind of scenario, my throughput is 1413 pieces. So, these many number of pieces, 1413 pieces in a day, that is a 8 hours working day, which is 58 pieces per hour. So, this is also the statistics here. this is working for how much percent of time is this waiting. So this is actually drain. This drain only has to wait for the material to come for more time. For this much number of time the material is passing through it. So these statistics can help us analyze further that what can be done. So these kind of outputs can help us to take the decision further that do we need to have some processes in parallel, or which is the bottleneck here that we can see. We will see that using charts as well. So we can see the throughput of any process. For example, if this single process, I open this one, we can even see its throughput here. So for 98% of the time this process was working, and for only 1.52% of time this was waiting for the material to come from the predecessor process. The total entries here are 473, total exits here are 472, that is one piece is there, this difference, that is being processed on in the present time here. So for any process we can see this thing. So these are statistics here. So next is dismantle section here, dismantle station. So dismantle station removes mounting parts from the main mobile units or create new ones. So from this my mobile units the mounting parts are removed. Next is pick and place robot that we have used here. Next is store. So what does this store use? This store actually stores the mobile units. These mobile units are these yellow entity. This is MU. For MU we mean mobile unit entity number, this one, this is telling this thing. So this mobile units are stored or can be stored in using this store, and one can define the size of the store by specifying x and y axis. For example, total 9 pieces can be stored, 3 into 3, total 9 pieces can be stored. This is the default entry. If we need to store 1500 pieces, I can say 100 into 15, because the throughput was 1413 in a day. If I need to store that in the end, I can make the capacity this much and put the store here. So by default capacity I have changed here, the default capacity here. So the default capacity is changed to 100 into 15. Okay. So next is place buffer. So the place buffer lines up the several processing units of the same kind one after the other. The processing units are connected and the mobile units have to be processed at each station. So other one is a simple buffer. This buffer, if it is placed between two plants or two machining, if for example if I say place a buffer here, this would act as a temporary storage. For instance, if I say in this case the machining time for milling is 10 seconds and the machining time for drilling is 20 seconds. For in each 10 seconds this milling would be doing a process, doing its work and putting a material, then that material would have to wait for drilling to take the material. So in this case we can induce a buffer here. So what would this buffer do? Buffer would keep storing this material from milling. So we can put a buffer here. This buffer can be put in between. The buffer will keep storing the material from the milling and it will keep sending it to the next process, that is drilling, that is having a larger processing time when and whenever it would call it. This is the use of buffer. So next is sorter. The sorter, as the name suggests, it arranges the mobile units by some sorting criteria. If you define, if I say if I can even change the properties of mobile units here. I can say this mobile unit is if I say this is a nut and I can put some attribute here, that what kind of nut is here this. So these kinds of attributes or different kinds of materials can be sorted by using this sorter. Then line is a kind of conveyor. Then we have, I would not like to put details of all the processes here because we are bound by time in here as well. So a few important processes like this is turntable. Turntable serves for modeling a rotating platform which turns a part around, like it would just, I could show the working of turntable here as well. So if in place of pick and place, delete this one and put my turntable here, so what would this do? This has to be actually put between these processes. So for that scenario, these processes are to be taken a little further. Now how would it process? For to look at the simulation, I need to slow down the speed. Okay, now run. So after the processing, that is after 1 minute of the processing, I could even see the turntable is kind of turning the material, or it is taking the entity and then putting to the next part, next process here. Similarly, we have turn plate. In this turntable can have only one piece, turn plate head can have multiple workpieces on it. So turn plate will have multiple workpieces. So these are all these kind of controls. I would come to some resources here. It is the workplace. When we when human operator is involved in this one, this workplace is put close to the workstation here. So this is a kind of a process. The process is workstation. So workplace is again put in here. Then there has to be footpath for the workers to move between the machines. So this is a footpath, and this need to be connected to the workplace. This is a footpath. I will take it a little further so that it looks clear. So this is a footpath that would be connected to the workplaces here. Okay, actually the grid snap is on. I would switch it off. Now it can take any position here. So even these labeling is not letting me view this very clearly. I can even switch these off. Now this footpath would be connected to my worker, or sorry, workplace here. And whenever we use worker, the worker always come from a worker pool. So this footpath has to be connected to worker pool as well. So also we have a broker who would control the whole process here. So in information flow, we have type of method that can be used. The method can be defined for different lines of maybe for different processes, and even for the whole room, that what kind of method is used to process here. Then in user interface, we can have charts, reports, dialogues, buttons. For example, if I have a chart here and I would like to see the chart for this process, this process, this process and this process, and maybe my assembly. So this chart could be shown here. So when I run my process, okay, let me make it fastest and run it again, apply and run. So in 8 hours of working day, what is this chart showing? For a 8 hours day, drilling was busy for about 98%. This milling was also busy for this much time. So this kind of scenario is coming, this kind of output is coming because these all times are constant, which are 1 minute, and there is this some blocking is there, and we have waiting in this drilling station 1. So when we change the time, when we try to simulate it to the real situation, so here I have changed some times here. I have put normal distribution with the stream value 1, that is seed value, and the time here is 1 minute 20 second, that is mean, and with standard deviation is sigma. So for this process also the time is changed, it is 1 minute 20 seconds and standard deviation is 20 seconds again. Now in this case also the time is changed. For assembly I have chosen considering it a manual assembly method, I have chosen a triangular distribution, and the time is also kept a bit larger. So in this case this 3 is my mode value, this is my minimum, and this is the maximum value. So these times are changed. So let us now see how does our simulation run. So this is my simulation. So earlier it was 14-13 parts. So here let me see. So we have only 462 parts. So this is dependent upon the time, because the time here is increased. It is about 5 minutes is taken for this process, assembly process. So the number of parts that are produced per day are reduced here. So also we can see the chart here. So in this case drilling is working for the 50% of the time, and for about 48% of time it is blocked, and it was just waiting for the material to come from drain for only about 2% of time. This one is 52% busy and 42% blocked. So this is assembly, this is the process which is having maximum time. So cycle time all depends upon this thing, this assembly here. This time was the mode time here was in, that was triangular distribution was 3 minutes, and the maximum time was 5 minutes here. So this blockage, can be omitted by using another milling process here. If I use another milling process here, this time, this drilling time would be reduced. Some example models here. So this is a basic assembly model. So what is this? The parts are coming from, this is main parts and parts, source, main parts, two sources are there, those are being assembled, and a drain is there. Event controller has also to be there in any process. Let me see continuous material flow models in which I see the use of turntable, open model. This will show how the turntable is being used. So this is the event controller. Let me make it slower and apply. Okay. So this turntable is turning or distributing the job one by one to different lines here. So in this case it is actually segregating the jobs. The blue kind of the color as can also be changed. This blue unit is being transferred to this upper line, and the lower line we have red units. This is a kind of turntable. So we have certain examples which are inbuilt in the software to show the potential of the software. For example, this is a 3D car body manufacturing model. So this is a 2-dimensional model here, and this is the 3-dimensional view of that. In this case, let me see the running here. If I run this model, see the components are coming here. So the workers would work on this one. And the components are being carried to the next processes through this conveyor. So, let me stop it here and let us see the three-dimensional view of this one. So, in this, the mobile units here are actually cars. So, these are the workers. So, here actually we can put the parameter for workers as well. For example, the work speed, the worker trailing speed, the International Labour Organization that has mentioned the travel speed for the worker is 80 meters per minute. So, that is the worker travel speed. For material handling, the speed of the conveyor can be fixed depending upon the time that is taken. For example, the maximum time is taken during this process. For example, at this station the maximum time is taken. So, this determines my cycle time. So, this conveyor speed has to be fixed accordingly. So, you can see the animation, we have worker pool here from which at which the worker would stay when he is idle, and we have work path, workstation, we have this processing, and these are the material handling, and the car is being kind of assembled, the accessories are put on and it is going out. This is all made in this software. So, this was all a kind of introduction about the capabilities and various user interface about the Technomatic software. So, I will take a break here, and the next session I will continue with my model, the model that I would generate using the times those were obtained during sensitivity analysis of my obtained optimized results. So, let us meet in the next lecture. Thank you.